Okay, I hope everyone is fine, I believe. So, the last time we met, we went through a lot of stuff, as you're seeing here, starting with just the basics of C++ program. Then we went ahead to look at variables and data types, and I tried to explain a lot of the different data types there. One which we spent a lot of time on is the logical data types. And then we also, the logical operators. So after talking about the data types, we also looked at the operators and the different operators that we talked about. The arithmetic operators, the common ones that you already know. The comparison operators, which also you already know. Then we went to the logical operators as well, and that's where we stopped. We also began with some examples and practice on these aspects. So we're going to build on that idea. First, just giving us a brief overview of how we create a variable. So we can use this first option of creating a variable. This when we don't know the initial value that we want to put in our variable in our container. Then the second option is this one here when, okay, after you've created your variable and you want to use it, you just call the variable name. Then you use a assignment operator to put the value inside your variable, just like this. So for instance, up here we created our initial variable called total with a data type integer. Then we created another one called gender with a type char. Then later on, we also went ahead to create a string variable. Now, one thing that you need to remember is in case you have forgotten to add this line or you don't want to use import the standard namespace and you want to go ahead and use the string data type, you must go ahead and put the std on this line. If you don't do that, you're going to have an issue at the end of the day because C++ compiler is going to fail to get where the string type is defined because that string type is also defined inside the general name standard namespace here, just as the C out and then the C in. Okay, so make sure you do that, especially when you're using a string data type. Then when it comes to using or maybe say assigning values to those data types, you just call that, to those variables, you just call the name of the variable. Then you use the assignment operator and then you put the value that you want to put inside that particular container or that particular variable. Usually I require or maybe say I advise people to think of an assignment operator anytime they see it as it's telling them to pick what is on the right hand side, which on our side of the assignment operator right now is 50, and then put it into what is on the left hand side. So given the assignment operator or the equal sign here, it simply means pick what is on my right hand side, which is in this case is 50, and put it into what is on my left hand side, which in this case is the variable called total. The same thing applies to this line, gender equals to F. So still the same explanation, the same meaning. Simply pick what is on my left hand side, on my right hand side, and put it inside what is on my left hand side. And the same thing happens for the second type of the variable declaration and initialization. You do the same thing. You create your variable. If you have the initial value already, you use that initial value to go ahead and assign your data type. Your value to your variable the same way. So the data type, then the variable name, and then the assignment operator and the initial value that you have there. So to use them, especially when you want to just display that result, you call the cout namespace for displaying outputs to the screen or to the users. Then you call the double less than sign or double left hand angle brackets, then the name of your variable. And if you want to add a new line, or if you want the cursor to move to the next line immediately after printing, you either use the NL or you use the backward slash, then the small letter n. But for that, you'll have to put it within a quote because it's a character and C++ compiler does not know it. Now, if we want to display just a string, just as we have done up here for hello world, we just go ahead and still follow the same syntax, call the cout namespace, then the two left angle brackets, then our string that we want to display. And in case we want to join it with a variable, we call again the double left angle brackets and then our variable name, and it ends there. If we want to add a new line at the end, we call the new line character, like that. So that's how we did it last time. And for the constants, I remember mentioning that the value of a constant does not change. Once you give it a value, it's going to remain there until for the entire lifetime of your program as it's running. Once you change it, you're going to get an error because you have already told C++ compiler that this is a constant and I'm not going to change it. So for a constant, make sure that you start with the keyword const, then the data type, and then the name of the variable, which should be in capital letters. And if there are two words in that name, you separate them with an underscore, just as we have done here. The acceleration due to gravity, then you give them its value. And if you want to use it, say just to display it out, you still do the same thing the way we have done it for the variable. Call namespace out, then the double left hand bracket, angle brackets, and then the string that you want to display, just in case you want to display the string. And if you want to combine it with your constant, you bring in the two double left hand bracket also, and then the constant that you want to display. And in case you need a new line character at the end, you add it here and you're going to get it there. Okay. So that's how we use our variables and constants in the cout, or maybe when we want to display it in the screen. Now, if we want to use it for any calculation, our variables and data types, still we do the same thing. We just call the variables and then we use it like that. So I'm going to skip this a little. This is an operator called the arithmetic operator. This is also an arithmetic operator which you use whenever you want to uh, perform any other kind of arithmetic operation that you want. Right, then for the comparison operator, the greater than, the less than, the equality, that's when you want to know what this number is equals to the other one. Here we use a double equal sign, and then when you want to know a number is greater or equals to, you use these symbols, which is the same thing that you had earlier. Then for the logical operators, as I mentioned earlier, we use it when we want to combine two or more results or two or more conditions at the same time. And we have three of them. We have the logical AND, we have the logical NOT, and then we have the logical NOR. For the logical NOT, it's as simple as just inverting the later result. If maybe say my initial result is a true, then when I invert it and I say not true, then it means it's false. So, and if it's not false, then I know it's true. Then for the logical OR, the logical OR says that given any two operands or any two conditions that you want me to combine, I'm going to give you a result of a true if one of those conditions or one of those results is a true. Anytime the result is a false, I'm going to give you a false. So here is true, here is true, we get a true, here is true, here is a false. But since there is a true here, we can get a true as the result. Here is a false, here is a true, but since there's a true here, we can get a result as a true. Here is a false, here is a false, but since all of them are false, our result is going to be a false. That's how the OR operator works. Then when it comes to the logical AND, for the logical AND, it says that the result is going to be true if both of the operands are true. The only time the only time that you're going to be able to uh just a quick one the only time you're going to be able to receive the result as a true as I mean the only time you're going to be receive a result as a false is when either of the conditions you're trying to add is a false. Say for instance here we have a true and then a true, and then we have here a false, then here we have here we have a true and then a true. True and a true is always a true for us. That's the only time we're going to have a result as a true. Every other time we have either of the result a false or one of them is true and one of them is a false, then our entire result is going to be false. Okay. All right. So let's go ahead and do a little bit some examples on that. So I'm just going to go to the new file. I think let me use this one. New. So let me save my file first, which I'm going to save it as, I think you already know how to save it. You go to file, then save as, look for your location where you have it. Like my file is on desktop, or my folder is on desktop where I'm keeping mine. So go there inside desktop, then give it a new name. Today I'm gonna give it, let me say assignment, okay, dot cpp. Okay, then I come to the save as type. I look for C++ source file, which is here. Click on that, then click on save. So now I have my file already saved. I can go ahead and now start doing my practice. So first thing first, I always display or print out something, so it's wiser for me to include the IO stream. So get the IO stream, include it right there. Then up next, this time around, I'm not going to use the namespace. I just want to show you what happens when we don't use a namespace. Okay. In our example here, we had imported or we had called the namespace std. But today I don't want us to use that. Let's just go ahead and ignore it, assuming it does not exist. So we go to our main method, which is our entry, or should I call it main function? The entrance or the door to our program. So this line is just a command, a comment. The C++ compiler is going to ignore it. So first thing first, create a main method, main function, take that. And usually if everything is correct, I'm going to return a 0, meaning my program ran on correctly. So I have a question that I want us to solve. And that question is, let me pick one question and then let's just start simple. Okay. Maybe we're looking at a greeting machine, which is basically what we had already done. Okay, but this time around I want to combine it with an input. So you're going to ask the user, or maybe say ask for a user's. Um, what should we ask a user for? Maybe ask the user for their first name, first and last name. Okay. Let me use a multi-line comment here so that I can easily break to the next line and continue. So once a user enters their first name and last name, this time around I want them to enter it separately. Okay. Now once they have entered it, we should print or display something like this. Hello, comma, then I put the last name, okay, space, or you can actually put comma, then first name, like this. Say, for instance, then we can add a quote like that. So, example, assuming we had the first name maybe it was, say, Danny, then the last name, so, comma, last name was, say, okay, let me use the anonymous names. Say the first name was John, then the last name is Doe. Okay, if this is what we have, then our display should be something like this. Hello, comma, Doe, John. This is what we expect to see. So that's what we're going to be doing in this for this particular question. So to achieve that, we probably may need to create some two variables which are going to hold for us the first name which the user is going to enter and then the last name. In this example here, I showed you how to read inputs from the user like this. Okay, but you first go ahead and tell the user what you want them to do. Say for instance, we are trying to ask them what is the result of adding 10 and then 5. Then they enter that value. Once they enter the value, we store it in the sum variable. Then after that, we can display the sum or the result which the users entered. Okay. Now, in ours, we need to first create the two variables which is going to hold for us our last name and then the first name. If you notice, I remember giving you the heads up here that if you don't use the namespace, if you don't import or maybe say call the namespace up here for the std, anytime you declare a string variable, you remember I showed that in class also last week. If we don't specify the std and we just call the string like this, we're going to get an error, which most of you saw that. So we're going to avoid that by explicitly calling the std namespace and then a string variable. Then we now call the variable name, which is going to be first name. We can actually declare all of them in one line. I hope that won't confuse you, so let me not do that. But this line here, if I do it like this, is basically the same as me having std string, then first name, then on the next line std string last name. So this line is the same. So if I comment this one out, this one is still going to work. If I comment this second two, line 12 and 13 out like this, then this one here is still the same as that's line that 12 and 13. Okay, now I can go ahead and ask the user to enter their names. So here I need to call the std for the cout, okay, which I'm going to say enter your last name. Okay, then I can, I'm going to leave it at that, the cursor at this line. I'm not going to add anything else. Then I will read now the name which they will enter. And to read an input from the keyboard, we use the in this term. And this time around, our double angle arrow is the right angle arrow. Okay. Then we're going to read that and store it in a variable called last name, which we have created up there. Make sure you had created that value earlier. Then secondly, we want to read, or maybe say allow the user to enter their first name also. So we go ahead and call the user, tell the user what to do, which in this case, we're telling them to enter their last name. So they enter the first name, and then we read that first name and store it in a variable called first name. So after this, we have already allowed the user to enter their first name and last name, and they are stored in a variable called last name and then first name. So we can display it in this format here, which is saying hello, comma, then the last name, then the first name. Okay, so let's go ahead and display that. So I'm going to use the cout to achieve that, which the first thing is having the string hello, okay, comma and space, right? That's this first string here, hello and a comma. Since our last name is now stored in a variable called last name and our first name is stored in a variable called first name, we're just going to display those last name and first name. And if you remember, this is how we use a variable in our printout. Okay, so we just mention first the angle bracket, the left angle bracket, because we're displaying on the screen. Then mm, yes, look, go ahead. Okay, let's continue. So it's going to be hello, last name, space, comma and space, then uh, our first name. So it's going to be last name. Okay, then a string with a comma and then a space. Then we bring in our first name like that. So we can now close this line. So I just save it like this. And once we run it, and how do we run it? First save code and then go back, look for our command line. So to get the command line, I'm going to come to the search bar here on my taskbar and I type CMD. So when I type CMD, it's going to open for me my command prompt. And immediately it open, it shows for me the command prompt. I'm going to come back here and then run. So when I run the code, I expect to see first the enter your last name, which is going to read my last name, which I will have entered, and then press the keyboard, store it in the last name. Then it will again display for me a prompt saying enter your first name, which once I enter my first name and then click enter, I'm going to be able to the program is going to read it and store it in a variable called first name. So after these two lines, the name I've entered, both of them are stored in either the last name or the first name variable. Then once I display it on the screen, to display it, I just call the lines like this and I'll be able to display that. Okay, so let's go ahead and do the magic, which is just typing CMD on the search and then clicking on CMD here, which let me open up this screen and I maximize it a little. So when I go to CD, my work is in, let me see, it's in the OneDrive. So I'm gonna go to CD, OneDrive. Then on inside OneDrive, there's another folder called desktop, which I'm interested in. So I'll go to CD space, then my desktop. How do I know it's in desktop? When I come to Notepad++, right on top here, if you see where my arrow is, right on top here, I have C users, then Nongom, then uh, OneDrive, then desktop, then Daniel, then C++, and then the assignment. So unless I'm able to see this order here, C, then slash this, slash this, slash this, slash this, and it's ending with slash C++, I have to know that I'm not yet in the correct location. So after desktop here, when I come up here, I'll see that what follows next is a folder name called Daniel. Then after Daniel, what follows next is a folder name called C++. So I'll go back here and type CD and then the name which follows, which is Daniel. Then what follows Daniel is a folder name called C++. So I'll have to come back here and type CD space C++. And then when I type enter, I can be confident now that I'm in the correct location. And now when I list, or maybe say when I check the content of this folder, C++, I should be able to see my assignment.cpp listed among these files. So that's how you actually navigate your command until you reach where you have your code. So now we go ahead and compile it using the J++, then the name of our file, which is assignment.cpp. Then the output object file is going to be, I'm going to give it a name, assignment. Like I say always, once you press enter and you don't see any output, then you know that there is no error. Your code has compiled successfully. So you can go ahead and now run it. And to run it, we're going to use this name here, which we have put as the output object file. Then we just type that name and press enter on Windows. But if you're maybe say doing this on a Unix environment, like let me say your Mac, or maybe say your Ubuntu server or Linux or any, you have to go ahead and first type the full stop, then the forward slash, then the name of this file assignment. That's gonna work for you. Or is going to take a lot of time to compile. I wonder what we had put here, which is delaying. Let's see. Basically, we don't have many things which should be causing an error. Did I miss something? Where are we? This is an IO stream, which should be the correct thing. This is just a main method which we had created, and that shouldn't take a long time. I wonder why it's still taking so long. Okay, let's give it a second or two. If it takes again another more seconds, I'm going to cancel it and then redo it again. Unless it's saying it doesn't see a code, which shouldn't be true. It has actually already finished the because it has created the object file already here. And the application file is here, so I wonder why it's still not doing the right thing. Okay, maybe let me open a new window. Okay, and I do the same thing. Okay, so let me see G plus plus. Why is it taking so long? It's actually correct. So let's go to CD, then OneDrive, then desktop. Actually, it's desktop. Okay, desktop, then Daniel, then C. Okay, so J plus plus and assignment.cpp. Oh, then sign. Now this one finishes very fast. I wonder why this one hang. Okay. So when you run it, actually open this second one. And if you notice, I used this. So I'm going to type assignment without T, which now is asking me for the first name, which once we enter it, we should be able to move. So I mean the last name can still use do, then the first name, we put it as Jane, and it prints hello, Jane, comma do. But I think we can even modify it and make it just print low space Jane, like that. So when I save this, come back here. Actually, let me use this one now since we had already. Okay, then can run it using assignment like that. So first name should, last name should be Joe, then still Jane, which still works. Can run it again. I mean, compile and run it again. Okay, so here this time I put do and John, like that, and it still works. Okay, so let me remove this and just remain with this one maybe. So the next time I want to run, I'm not going to navigate the whole thing. I'm just going to stop there. So this is how you attempt this question. We could go ahead and try another question. So let me assume this one here was the question 1. Okay. Then for question 2, or even going to create a new file for that. Later on me, I'm going to delete them, but for you can keep it. Okay. All right. So my second question, which I want us to look at, would be okay. I thought somebody wanted to say something. So for question 2, I can decide to create a new assignment, or let me just leave it here. So for now, let me just print out some new line characters. So which is going to be first is going to be this. I want 2 spaces added for me. Then the second one is going to be this one here. All of them still just new line characters. So, oh, actually, instead of just doing that, let me print this. Let me print just the asterisk order. Okay, let me print those lines. Then I repeat it again. Right. So, okay. Mm, okay. This should be enough for whatever we want to do. Let's move to the next question. So for question two, I want us to look at, let's say, a temperature converter. Yeah, I think we had tried this one sometime. Okay, so for the temperature converter, what we are going to do is convert from Celsius to Fahrenheit. So we can say write program to convert Celsius Let me just bring it back to the new line here so that I don't move anyway. To convert Celsius to Fahrenheit. Using the formula. What is the formula for converting from Celsius to Fahrenheit? The math genius in the house. Okay. So it's going to be the temperature in Celsius multiplied by 9 divided by 5. Okay. Then the whole thing, the whole result, we're going to add 32 to it. Okay. Now, what we could do, we're going to create a variable which is going to store our temperature in Celsius. Then we're going to create another variable which is going to store our temperature in Fahrenheit. Then later on, we shall use this very same formula to get the result. So first, we can start by just hard coding the value of Celsius. Then later on, we can ask the user to enter the value of the temperature from the keyboard. And to do that, let's look at this. So we create our integer variable. I think temperature values can be a float, right? So I think let's use a float. And it says Celsius, or the temperature in Celsius. It's going to be, initially we can put it at, let's say it's very hot today. So you say 40 degrees, 44 in probably 0. Okay. Then for our Fahrenheit, it's also going to be a float. Temperature in Fahrenheit, it's also going to be a float, but this time around we don't know the initial value. So we just leave it at that. Now, we can calculate our Fahrenheit using the formula that we have up there, which is equals to our temperature in degrees Celsius, which is going to be Celsius. Then we multiply by, let me add a small bracket here, 9 divided by 5. Okay. So the whole thing, we add 32 to it, like that. Then once that one is done, we can go ahead and print our results. So I'm going to say std cout, and we say what message should we put? Celsius, or let's put Celsius. I'm trying to see where to add say degrees Celsius is, let me close that out, and then I put my Fahrenheit like that. Save this. I'm not going to add a new line. Then in the next line, that's when I will now add my text, which is this, and I call it Fahrenheit. Okay. Then here I can add my neoline character, maybe like this. Then I close. So this one here should be able to give us what we require. Now, when you save this, we are going to, the first thing we're going to see here, we're going to first hit these lines, which is a first question. And then when I come to question 2, that's when we shall see this result here. So it's going to be the result, or maybe say it's going to be 40 degrees Celsius is, then the value we're going to get here after this calculation. Then I say, is it degree Fahrenheit or just Fahrenheit? The math geniuses in the house have also slept. Okay, let's compile and run. So G++, the assignment .cpp. Okay, in our output folder or output file, the object output file is going to be still assignment. Replace it with that. And there we have missed something. You see, we have not added the std for the end line. So where are we using that? End line here. Remember I told you, if you don't import the namespace here, the std namespace, everything you do for the cout, for the string, for the end line, you must add the std namespace here. Okay, for all of them. If you don't do that, you're going to get the error which we have just seen. All right, with that out of the way, we can save it, see if there's any other error. I think it was complaining with for only this end line. Yeah, basically that's just the only error. And it's saying it's expected that. Seems like we missed semicolon here as well. Okay. Save this, clear screen, compile again, assign main.cpp, file name, then the object file is going to be assign. This O here is small letters, okay? A small letter O. Don't put in anything. So I press enter. If we don't see any other output, then we know it has compiled successfully. And now it's again taking its time, which is not supposed to be. So I'm going to cancel it, run it again, and clear the screen, run it again. So assignment that like that. Then it still asks me for my first name. Let's say Doe John. Okay, then here it goes ahead and say 40 degrees Celsius is 72. It's actually stripping away the decimal places, if you have noticed, in our printing. So if you want the decimal places to come in, what do we do? Good assignment for you. So now we are going to allow the program to ask us temperature in Celsius before we display or before we calculate the temperature in Fahrenheit. We first allow the user to enter the temperature in Celsius. So we go ahead and say std out, and then the message we want the user to say enter temperature in Celsius. Okay. So once the user enter that, we're going to read that using the cin in our bracket. So then we store it in Celsius. Now something that we need to know, sorry, Celsius. Okay. Something which I'm not going to tell you yet until we just encounter it. So when we save this and then come back to compile our code again. So to compile again, we call the file name, then hyphen o, then the name of our file that we want our object code, or maybe say the output result to be in. So when I call the object file now, still I'm going to have do Johnny, and say that. Now it's asking us to enter our temperature in Celsius, which I can say it's 50. So when I say it's 50, it's going to calculate that and say. So let's use a calculator to prove if that is correct. So our formula here says, let me get my calculator. Okay. So this is my calculator. Okay. Let me put it here. So the formula says it's Celsius and the value we have entered is 50. Okay. Maybe put all of them in brackets. So where is my bracket again? Let me change it from standard to scientific. Okay. So I put my bracket and I say it's 50. Then we multiply by, open a bracket here, and I'll say it's 9. Where is the division sign? Divide by 5. Close this bracket. Then close the inner bracket also. So here it's saying it's what? It's 90. Okay. Then we come here and say plus. Are you sure we are correct? Then plus 30. Is it plus 32 or minus 32? Meaning we also got a wrong result somewhere here. Let me get back here and then we see. But this result 82 is not correct. Meaning our formula is not working correct. You get. So if that's what we have, we probably missing something. What are we missing? Let me see what we're missing. What are we missing? That should be a correct formula. Let me say 37 multiplied by 9 divide by 2. Divide by 5. Gives me 66.5, then plus 32. It's actually a correct formula. It says correct actually. Then I wonder why this result is not what we got. Something is wrong somewhere. Say that our program is lying to us or it's not doing the correct thing. Because when I get this, which should be a correct thing, let me see, 50 here times 50 times 9 divided by 5. Get a 90, then plus 32. We expect a 122, not a 82. Where did we go wrong? Let's try something else and see. Let's run again. Sudo. That's what we call a logical error. The program runs, but then you get a wrong result. So let's say it's 30 and it says 62. Let me see. 30. It's actually not performing the calculation. What it's doing is just picking what we have and then adding 32 to it, which is not correct. So where are we missing it? So once it get the 32, this one is not working. Let me first remove this bracket. Okay. So when it's compile and run, then we go ahead and run our assignment. So I put the John, then I say it's 50 again. Now it works. So it was ignoring this bracket here, which we had put earlier. That's why it wasn't getting it. So now it's getting the correct thing. Okay. Now that's how you solve a problem which is like that. Now let me give you something a little bit harder. Okay. But let me see which one is a little bit harder. But the rest is just the same thing, maybe. Okay, let's try to calculate the area of a cycle, maybe, and its circumference and see. So to do so, we can, let's try another question. So I could say, again, I'm just going to copy these two lines. This one's what we had here. Or even, just to act as our separator, I put it right here. Okay. Now let's try another question. Say question 3. And in question 3, we are trying to get the okay. So these are two ways of adding comments in our C++. So we just call it psychomat. Okay. Then I'll say uh, given why don't I just read it from the keyboard straight? So you can just say create a C++ program that inputs the radius of a circle and calculates the area and this circumference, like that. So for the formula, I think the formula for area is area of a circle is equals to, what is it? Pi. That's all. Do you have a symbol for pi here? No, I don't have it. Okay, let's assume it's just called pi. Then we multiply it by radius squared. Okay, so radius times radius. Then, sorry. Then for the circumference, its formula is going to be 2 multiplied by pi, then multiplied by the radius. That's, I think, the formula. So after the users entered the formula, I mean the radius, we can go ahead and create the value of pi. So we can start by, since our value of pi is always a constant, we can start by creating a constant, seconds, and can call it a float, or this time around, let's use a double. Since I'm just going to have only few decimal places, so it's seconds, then pi is equals to, let's use 3.14. Or we can add some 2 more digits or 3, like that. That should be enough. Then we create another variable for the radius. Our radius is going to be an integer or a number. So it's a radius. And initially, we don't know the value of radius because it's going to come from the keyboard or the. So after we have gotten the value of the radius from the keyboard, we're going to ask the user to enter it. So we ask the user to enter it, then we can go ahead and start calculating the A. Oh, we actually need 2 variables, area and then circumference. So I'm just going to create one, which for area, it's gonna be a float. Let's use a double this time around, double precision. And then I'm going to say it's gonna be area. Then for circumference, I'm going to create it when I'm calculating it. So we go ahead and now write std cout, then let's say enter the radius of a circle. Okay, once they have entered the radius, we are going to read that radius. C in. So we read the radius and put it in a variable called radius, which we had created earlier. So we calculate the area of the cycle by calling the value of pi, which is pi, multiplied by the radius, which we had also gotten from the keyboard, then times radius. That is radius squared. Okay. Then for the circumference, we are also going to do the same thing. But for this time round, we are going to first create that variable. So it's going to be, let's use a double also. So can just say circumference. That's going to be a little bit too long. So we can just say circ, like that. That's not a very descriptive name, but I just don't want it to be too long. But anyway, let's follow the principle. Okay, so it's going to be 2 times the value of pi, then times the radius. Okay, that gives us our circumference and the radius. So we can now go ahead and display our results and say std the out, saying the area of a circle of radius. Then press, maybe put the name of the, or the value of the radius, something like that. Then I'll say std, or even, why should I spend a lot of time doing all that? I'll just say, anyway, space is, then I put the value of the area, like that. We add a new line character to that, /n. Then you save that. If I don't want to go so long, I'll just say radius is equals to, then I put in radius. So I can just simply say std c out, and I say area is equals to that. Then I put my area, and then I can add the inline character. Std and line. That way can still be the output, but I want the name to be the output to be a little bit descriptive. I'm gonna do the same thing for my circumference. So I'll say C out, and I'll say the circumference of a circle of radius. Then I'll put the name, the value of the radius. Say radius. Okay. And I'll say std c out, and then I put my else. Then I can put my circumference. Okay, then a new line character. This time round, let me use the end line. Just want you to get familiar using both of them at every time so that you know what is happening. All right, so that's basically it. Now, when we go ahead and save this and run it, let me see if we have made an error anywhere. I don't see one, so let's go and compile this code and run it. So J++ assignment.cpp, then the output or the object. Okay, so when we run, the first question asks for the first name. The second question asks for the radius, for the temperature in Celsius. The second one asks for the radius of a cycle, which is 40. And it calculates for us the radius of a cycle and displays for us the result. Like that. Great. So that's how you would solve such a question. Okay. All right. Let me see if we have any other question. All right. I thought that one was going to be a little bit harder. And let me see one which is a little bit hard. I'm going to keep the rest for you to try it out. So I'll just simply put them probably down there, and then you'll be able to let's test another operator which in this case is which operator should we test? Great. We've gotten one idea here. Amongst the questions I have, this one here is going to be a little bit interesting for you. So, question 4. I hope we can do like about, I mean, can it reach 10? If it can reach 10, then that's okay. Then we stop there. And the rest will be for you. So, the next question is going to be focusing on the modulo operator, the one that uses the remainder sign. So you could think of the modulo tick, which we're going to do two examples in that, and that should be enough. So given a number of seconds, okay, let me just create a little, like create a C++ program that takes in, okay, let me, takes in any number of seconds and extracts the hours, comma, minutes, and the remaining seconds. Okay. Say, for example, if maybe say the seconds were given were like, let's say you have 300 seconds. Okay. Yeah, let's say we have 300 seconds. And this one here is going to be something like how many hours are here? Let's assume we have like 3 hours there. There's going to be 3 hours. And maybe it's a comma, or we can use a colon. And then we have like 30 minutes. That's in case I'm not guessing wrong. And then 10 seconds. So that's what the kind of output that you'll give out. Okay. So let's hard code this. We first start by the minutes, or maybe say creating a seconds that is not coming from the keyboard. So you could say the total seconds is going to be, let's start with that example still, 300. Okay. Show me this is the total number of seconds that we have. So we want to know in these seconds, how many hours are there, how many minutes are there, and how many seconds are there. So first of all, what you should know is that in a in a minute we have 60 seconds, but in an hour we have about 36, is it 36,000? Yeah, I think 36,600 seconds. So if in a minute we have about 60 seconds, that means in an hour we have 60 minutes. So since we know that already, we can use the the modular operator to first extract the hours out. And how do we extract the hours out? There is an operator there's an operator which is called the remainder, or maybe say the dividend operator, which extracts for us only the whole part or the whole number part of our task, and then later on it returns for us the remainder remains part. So we're going to just use those two operators to see how we can achieve this task. Okay, so now that we have this, I'm going to extract my hours, which is going to be in still an integer. So I'm going to say int hours, which is going to be, so in this total seconds that we have, we want to know how many hours are there. Okay, so to achieve that, so after we have gotten the number of hours which are remaining, it's just simply going to be that we first divide this. Since we know that in 1 hour there are 360 seconds, we divide that, I mean 3,600 seconds, we divide these total seconds by the seconds which are there, which is now in this case is 3,600. And if we don't have any hour part of it, it's going to return for us a zero, which will mean we don't have any hours in these 3,000 seconds. Okay. Then for the minutes, so after we have x divided this by 3,600, what is going to remain is going to be the total minutes. Okay. So we also go ahead and call still this, but this time around, anyway, let's first do this. So this divide by the remainder part of it is going to be the seconds, I mean the total seconds which are remaining in a minute. Okay. Or in other words, you can just say this is the remaining minutes. So after we have gotten this, it's still going to be in seconds, but we have to convert it to minutes. And to convert it to minutes, we have to divide it by 60. Because in 1 minute, we have 60 seconds. So you divide this by 60. So first we extract the remaining minutes. After getting the total hours, which are there in the total seconds, we go ahead and extract those hours there. And what remains, the remainder, after dividing by this, is going to be the total, the other minutes remaining in these hours. And those other minutes will also be combined, I mean, made up of the minutes and the seconds also. So we first extract those ones, and then later on, we extract our minutes from it, or we convert the minutes from there. How do we know that? When you divide any second by 60, we're going to get the minutes. Okay. Then lastly, what's going to be remaining in that total second is now going to be our seconds. So what we had not divided by the seconds is basically what's going to remain for us. So in this case, still I will take the total seconds. Then this time round, we use the remainder operator still, but here we divide by 60 because those are the total seconds that we have remaining after extracting every other thing. Okay. Right. So let me display this result out by saying std out. Then I'll say um, the total seconds that we have 360, whatever second is that, and it say seconds. All right, like that. Let me put this on a near line like this. I'll say I'm just going to put all of this in one line. Let me put an equal sign here at the end. It's equals to the number of hours that we have. Okay. All right. Then the colon there. Then I'll say the number of minutes that we have. Then I put the colon there. And I say here is minutes. And then lastly, the number of seconds that we extracted. So we say seconds. Okay. Like that. Actually, here we don't need that. We just can put a full stop or anything. Right, then lastly, I can actually put this also in a new line, but let me just put it at the end here since we still have a space. Then I say the end line, std end line. Okay, so this should display for me. I think I need to bring this separator also still right here. Okay, so it's just separated down here. I should be able to get a space. Okay, now let's first run this. Then later on, we're going to come and modify this and allow these total seconds to come from the keyboard. Okay. Right, so we save that, come here and then compile and run it. G++. Let's say assignment .cpp. Then we go on with the output and the assignments. Okay. And we expected a comma or a semicolon at the end there. So on line number 92 and 94, we are missing something. Exactly. So I missed here. I missed a semicolon here. See how you should be very careful when you're typing your work. You don't forget anything. Save this. Then you come back here and compile it again. And now there's no output, meaning the code compiled successfully. Still we have a do here, John here, Johnny Walker. Then 22 degrees Celsius, 71 degrees Fahrenheit. Then a radius of 20, yes, a temperature of that. Then here, this is what we have. So in 300 seconds, we have 0 hours in it, but we have 5 minutes in it, and then 0 seconds. How do you know it's 5 minutes? 5 times 60 gives you 300. Now, let's modify this program and allow it to receive these inputs from the keyboard. So we're going to remove this hard-coded value here. Just have a declaration here. So here now we can go ahead and type cout the prompt and I say enter the total seconds. Okay. So once they enter the total seconds, we are going to read it cin and store it inside the variable called total seconds. Okay. Once that one is done, we can now go ahead and calculate our seconds, and then we save our code. Let me bring these lines and put it here so that we have some space there. Okay. Right, like that. So you come here and so here we compile again. Assignment.cpp. Our output object file is going to be assignment. Okay. So everything looks good. So we run it. Enter our names. Johnny Walker. And there we go. So for the temperature, I didn't enter any value. I just pressed that and then it went through with it. So I didn't enter any value. It was day 0 and then it just gave me this. Okay, so here also I didn't enter any. Something went wrong. I actually didn't enter anything. My computer is playing games with me. So let's compile again and then run it. Now this time, I'm going to enter do Johnny, which is 40, which is 10, and the total seconds that we need is, let's say 5,000. So in 5,000 seconds, we have 1 hour, 23 minutes, and 20 seconds. That's basically how you go ahead and extract the seconds given any other minutes. Okay. Now, something which goes along with that is, let me see, I had a question here which does something like that. Okay. Let me see this question. Yeah, I think this one also looks good for us. Okay, now there is something here that I want us to look at too. So, hoping this is question 5, but I think we should stop at question 5. That's enough for today. Others, you're going to continue with it yourself at your free time when you receive the questions. So now the question is simple. I call it a digit extractor. So in this, your program should input a, let's start with a 3-digit. A 3-digit, a number, and print each digit on a new line using this operator and then the percent operator or the modulo operator, the normal division and then the percent operator. Okay, so an example let's say you have a number eg. So assuming that the number is 7 2, okay, let's say 753. So your output, the output, or what we'll see on the screen, we expect to see something like 7, then 5, then 3. Excuse me. Then 3. That's what you expect to see. So you get this number, you extract each and every number and put them in new variables, and then you go ahead and. So how do you extract the first number? How do you extract the next number? How do you extract the second number? And etc. If you remember your lower classes math, the tens, something like the digits of the tens, the hundreds, the thousands. Oh, it starts from the ones, the tens, the hundreds. So the tens, the ones is from 1 to 10. That is just one digit. When you jump to 2 digits, we are now in the tens. When you jump to 3 digits, we are now in the hundreds. We jump to 4 digits, we are now in the thousands. We jump to 5 digits, we are now in the hundreds of thousands in that particular order. Or tens of thousands, then hundreds of thousands. Then, which other digit follow next? Oh, interesting. I'm not also going to say it. Anyway, let's look at this program. So assuming that's the question we want to get its answer, what the question says that we need our program should input a 3-digit number. So let's create a variable which is going to hold that 3 digits number, which in this case we can start with the one that we have, the 53. Then let me bring this one here like that. Then print each digit on a new line using the division operator and then the remainder operator. So to achieve that, we first go ahead and maybe extract the numbers, okay, or extract the digits. So I extract the digits first, and to extract the digits, we're going to look at, so we have 3 digits numbers, meaning the tens that we are, the places that we are in, it's in the maximum is the hundreds, okay. So to achieve this, we're going to get the number which the user has entered, or maybe say the 3 digits number, then we divide by 100. So when we divide this one here by 100, what is going to happen here is going to just pick for us the first digit and then return it for us. Okay. Then in the second, the same thing that we have done here actually. Remember here, we divided by the seconds and then it returned for us the total number of hours which are there. Then here, we first extracted the remaining seconds and then later on we got the minutes out of it. Then afterwards, we know that the remaining seconds now is the only seconds which are remaining. Okay, so with this also, to get the tens digits also, we are first going to, after getting the hundreds, which is going to get for us this first digit, which is in the positions of the hundreds, then at the tens, we first need to extract the remaining digits here, which is this 5 and 3. And to do that, we are going to use the remainder operator. So it's going to be the number divided by number divided by the 10, and then we extract the remainder. We use the remainder of that to extract this other 5 which is remaining. So this one here, because of the 10, it's going to divide and I shall have a 7.5, but it's going to return for us only this part here. Okay, so once we get this, we can now go ahead and use the remainder operation to divide the entire result and then get our, actually, this is what's going to happen. Once we divide this by 10 first, the result is going to be 75.3. So this number divided by 10 is going to give us 75.3. But since we don't have any, we don't record normally the decimal part is extracted out, it's going to just give us 7.5. So when you divide it, you get now the remainder, and it's going to give us now that's 7. Okay, so the last one now, what is remaining is what is in the ones, the single digits numbers, which is basically just that particular number, extracting the remainder out of it, which should be what we expect. Okay, so now we can go ahead and print each digit on a new line as the question requested. So to achieve this, we're going to call the cout std cout, then you print our, the first is going to be the hundreds. Okay, then we add a new line std and then the second one is going to be the tens. Then we also add the new line character. This time around, let me use a /n. Okay, then the third one is going to be the ones. Okay, then you add our new line character as well. Say endl, and then we end there. So basically, that's how we can extract the digits. Okay, so when we run this, or we compile and run it, assignment.cpp. Okay, and let's say we put assignment there. We are missing a colon somewhere right here. Okay, then you can go back and says hundreds was not declared. Hundreds, it wasn't declared because we had an error there, but now this one should work. Okay, now I can run it, and we enter the last name, Johnny. The Celsius is 20, 60. Total number of seconds can give 6,000 or 600,000. And our number is here. I think we may need to first print the 3 digits number first, so that we know what we are extracting. So I think let's first print the 3 digits number. Say std cout the 3 digits number. Let's say it's then I enter the number. Okay, and I can use a neoline character to end that. So now when we save it, we should expect to see something clean. So assignment, then do gem 10 3 Total seconds is 10,000, actually 100,000 seconds. It has so many hours in it, 27 hours. So now this one looks better. So the three-digit number is 753. Okay. Then printed in near lines, the single digits are this one and this one and this one. So how about we change this one now and allow the user to enter the digit from the keyboard. So we're going to remove this one here. Just declare a variable without the initial value. Okay. Then you type C out. Okay. Then you say enter a three-digit number. Okay. So once the user has entered the three-digit number, we read it std. We read it out. Okay. And give it to number. So after that, everything now should be fine. Okay. So clear this out. And then I compile it. Assignment.cpp. Let's say it's just assignment. All right, run that. Enter the name like that. Then our temperature in Celsius is 1 degrees. Then plus, it's actually 2 degrees Celsius, 20. So this should give us 0, 0, then 20. Okay. So we enter our digits remaining, which in this case is going to be 567. Okay. The digit we have entered is 567, and then we have 5, 6, and 7 in that order. Or we can actually add something here and say uh, first digit. Okay. Close that and say it's this. All right. Then let's say second digit. It says that. And then the third. I think this one will confuse. We can just use this once. Says this, and I change this one here to tens. And here we put it as hundreds. All right, so now that's gonna work better. Now, what if we have 4 digits instead of 3? So I change this to a 4-digit number. Now, what we need to do, we're going to do a little bit of a change here. Okay, so here what we're going to do, we shall have int, and then we add a thousands here. Okay, then it's going to be number divided by 1000. Then when it comes to the hundreds, we have to modify this a little first. Okay, then we can extract our 100 using the remainder operator. So here now we shall add one more line, which in this case is going to be thousands. Okay, then you have thousands here. Okay, now this should be good for us. So when you save this and then you go back and run it, g++ assignment.cpp. Okay, then you say assignment. Okay, then I run assignment, and I said the last name is Doe. Then I have John. Then I said the Celsius is 3, cycle is 5, total seconds is 23.45. Like that. Interesting there. Then we have the 4 digit numbers can be 4, 5, 6, 7. Okay. And we are missing something. So it's not supposed to do that. Let's, for the hundreds, it's not, it's supposed to extract only the 5, not everything. So it should give us the 5, but it's extracting 4, 5, which is not correct. So let's change this to, let me see. Let me see. What what is not there? Let me see what is not happening here. Okay. Actually, what we need is here. We are extracting 2 digits instead of 1. But we just want the 1 digit only. If we divide by, if we divide, if maybe say the number was 4, 5, 6, 7 as we did, then we divide by 100, we're going to get 45. Okay. So when you divide by 100, I think this is going to give us, it's going to extract for us this other part, which is not correct. So what we need is the last digit only. If we needed 2 digits, that's when we would be having 100 divided by 8 here. Okay. So it's supposed to be 10, not 100. All right. So when I save this one now, go back and compile and run it. J plus plus assignment. That's CPP. Okay. Output. Then I say assignment. Mm, spelling error. It's assignment. Okay, it's assignment. Okay. So now I have a door, a Jenny at 30, 36. Then total seconds is going to be 4, 5. Then the 4 digit number is still 4, 5, 6, 7. And it still extract that. Let me see. But that's not true. 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 Unless it didn't compile correctly. Let's compile again. Oh, we didn't save. Let me see. I've actually saved. So let's clear the screen. Then I compile again. J plus plus assignment. It's actually assignment.cpp, and I type assign the output, then assignment. Okay. Now after that, when it's changed this, it had not compiled, so now it should work. Jenny 30, 44. The total seconds is gonna be 454545. Okay, then the 4 digits number is still that. Now that one works correctly. So you extract the last digits only instead of extracting 2 digits. So when you put a 100 here, it extracts for you the first or the last 2 digits. But we want only one, that's why we are putting 10 here, 10 here, like that. Okay, I think that should be enough for today. We can't do this the whole time or the whole day. All right, let's end it here for today. I hope this one was helpful. We shall meet some other time, hopefully. Okay, so gonna stop sharing now.